Hello friends, welcome to Unacademy and welcome to today's session. Today we are going to discuss about the another funda in computer networks, that is topologies. Topologies plays a very important role in computer networks in order to reduce your delays as well as in order to increase line efficiency. So topology mainly is talking that we must not form any kind of a cycles. If you are having a cycles in our topology, then there may be a chance of redundancy of the packets. Therefore, the efficiency is going to be falling down. So, what are the types of topologies are there? Which topology is playing a crucial role in real-time data transmission? Before entering into the details, let us say our anthem crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. About myself, Srinivasrao is having more than 15 years of experience in the subjects of database, computer networks, and operating system, and others too. Throughout my journey of GATE, I taught in many premium academies, including GATE Academy, and Gate Forum and Vani and many others. And my journey also including generation of the first single digits and double digit ranks. So many of my students are working in a software companies as a good software engineers and after completion of their post graduation in premium institutions. So you also can be entered into the premium institution just by clearing the gate examination. So in order to obtain the admission to get the quality of content from quality of the educators, you have to take the subscription. There are two modes of subscription, 12 months and 24 months. So 24 months can be opted for third and second year students. 12 months can be obtained by fourth year students. This subscription also consists of many kind of doubt clearing sessions like quizzes and others too. So after taking this course and subscription, you are 100% confident to clear the GATE examination, as well as this knowledge is very much useful in clearing your interviews. So in order to get the admission into Unacademy, use my referral code to get the maximized discount. Unacademy is also offering Iconic Batch, which is a one-to-one interaction by the faculty and the student. So you are going to get the complete guidance program in order to clear your GATE examination and acquiring the knowledge. So that also you can able to obtain. The batch name is called Iconic, which is implicitly having plus courses. So in order to, if you're having any doubts to clarify all your doubts, just fill this form. Then an academy is going to direct a faculty member. They are going to guide you completely. Let's Crack Gate CSC is our YouTube channel. Subscribe our YouTube channel and use my referral code to get the maximized discount. Hit the bell icon for latest notifications and updates. Now, the first kind of a topology, when you are talking about the topology, it is nothing but organization of nodes. Organization of nodes. So there are few varieties. One is based on shared mode and the other one is based on non-shared mode. So very important concept as far as a funda concerned. So you need to have a good grip on this topology. Really, if you become a network admin or a system admin, you're supposed to know that how to organize your node without having a loops. That's called as a what concept a sync tree. You're supposed to maintain a sync tree such that you're going to see that efficiency and throughput of your network is going to be very high, Otherwise, you are going to see that circulation of the same packet n number of times you are going to get. That's why topology playing a very important role as one of your main responsibility of your system admin and network admin. So in shared mode, if you are talking, there are a few varieties. One is called bus, which we mainly used in novel network. The other one is called which mainly used in IBM token ring. And the other kind of topologies in a non-shared mode. Non-shared mode, last class we discussed that non-shared mode is nothing but dedicated mode. So in dedicated mode, we are having a few more topologies that is called a star, and you can also call it as a what? Mesh. And we are also having other kind of topology called hybrid. And we are also having three topologies. Among them, which topology is rarely, that means what, which topology we often see in our current network or real-time network is nothing but what? A star. And a big corporate network, they are going to have a concept called a hybrid. And your cable TV network is following a bus topology. And your IBM token ring is following a ring topology. So if you are using ad hoc networks, we are using a concept called mesh topology. So every topology is having its own significance in the real-time scenarios. So if you are looking here, what is the meaning of a shared mode? When we talk a shared mode topology, here medium is under shared. Medium is under sharing. So when you are talking that medium is going to be under shared, that means several nodes can be connected to your particular channel. So using that, the first variety we are looking, that is called a bus, which we are mainly using in a novel network or a novel network. So one of our oldest network is a novel network where all the nodes are being connected using with the help of bus when you don't have the concept of hubs and switches. And when the hubs and switches have come into the picture, then this novel network is being replaced with a hub and switch network. So what the bus is talking, there are very few important points we would like to see in bus. The long trunk cable is the point number one. Is that a long trunk cable or a transmission cable is being shared by several nodes. Is being shared by several nodes, and those nodes are connected to your bus with the help of T connectors. So these connectors are very specialized connectors which we mainly used in bus topology, such that nodes are being connected with the help of T-shaped connectors. So here there is a node 1 and there is another node 2 and there is another node 3. So that means what, three nodes got connected or three nodes are being shared your medium. This is the end of a medium we need. How long the particular data signal or a bit is being transmitted. It is going to start from the starting end because the cable has a start as well as the cable has got end. Now among them the nodes are being connected. So we know that it is inexpensive concept because we are using only a single channel. But you observe carefully, whenever you are having a concept of a sharing, then there may be a chance of collisions. Why there may be a chance of collisions? N1 can able to place the data and this guy can able to place data and this guy can able to place data onto your medium. Therefore, what are we going to do? We are going to see a concept of what? In order to avoid the collision, we see that only one particular node is supposed to place the data onto the media. So such kind of a rule is telling that only a node, one node only can able to place the data at a time because many nodes are being connected to the same. So other nodes also there may be a chance of keeping the data onto the media. So to avoid the collision, what we are saying, only one node can place data at a time. So when you are talking that only one node can able to place data at a time, then what is going to happen, friends? You observe carefully. As soon as N1 places the data onto your media, then this data is going to take a circulation on your medium, and it is going to stop exactly at the end of the medium one. So what do we understand? Data which is being placed, data is traversed from one end of the point to another end of the point, one end of point to another end of point. This is called a multi-point, another end of a point. So now, once the data is circulated onto your media, what is going to happen? I feel that just N1 release the data, then N2 are connected to media and N3 is also connected to media, and the data whatever you are placing onto the media, the data will be hand over to N2. It's a dropping there, and the data is also hand over to N3. That means data packets will be hand over to the other particular nodes, those who are connected onto your particular channel. So that's why you see that always we find only one sender at a time, only one sender at a time. And you see that there may be a chance of many receivers, maybe many receivers. So that's why what I want to tell you, friends, this is implying a one-to-many communication. That's why we learned in the last class that there is a concept of broadcasting and there is a concept of unicasting and multicasting. So bus is one of the example of your broadcasting. Now you see only one node can send data at a time, can send data at a time. So when I say that only one node can send data at a time, not by the many nodes, and you see that I'm using a concept called half duplex communication. So the bus is meant for what? Half duplex communication. If you are doing a bidirectional, then there may be a chance of what? Collisions, because the cable is under shared mode. And the next important point is because of half duplex communication, last session I said, because of half duplex communication, your efficiency cannot be greater than 50%. So your efficiency is lesser than is equal to 50% only, because only one node is able to using your channel. And next important point is that you see nodes are connected with the T connectors. Nodes are connected with T. T stands for tap connectors. And the next point is that this is inexpensive. Why this is inexpensive? As we already learned that because how many channels? Only one channel. And apart from these important points, how the data is being transmitted, if you understand carefully, the data is being transmitted onto media from one end to other end. There is a starting point, there is an ending point. So in the remaining parts, the nodes are being connected with the help of T connectors only. So nodes are connected to bus. Bus is nothing but a long medium. Nodes are connected to bus. Daisy chain manner. This is an important point. Daisy chain manner. Linked points. That's why bus is called a multi-point concept. So that means what? Loads are connected like a what? Links and links and links. That's why it is called as a what? Daisy chain manner. So what are the main problems of this? Where we are using the drawbacks we are going to learn, and what is the real-time application of your particular bus, as we already learned that Really, you see that cable TV network is one of the real-time example of your bus topology, as well as one more real-time application, as I already told you, novel network or novel network, which is completely running with the DOS operating system. Now you observe, friends, what are the drawbacks here? The drawbacks is you are limited to op duplex, and the second drawback is no privacy and security. Why no privacy and no security? Because only one channel that is being shared by others. If I release my data, then automatically it is going to all other nodes. That's why no privacy and no security. And the next one is if backbone fails, backbone means media only. If backbone fails, then what is going to happen? The network, there is no network. Then there is no network because your cable got damaged. You need to replace the cable. And one more drawback is there. What is the drawback? Please understand, all these are all 1 mark questions. We are working for 1 mark, especially in a net examination. This theory is very much useful. And next one, please understand, if tap connector fails, if T connector fails, then what will happen, my dear friends? There is a what? Noisy. There is a leakage of data. So leakage of data, we can call it as what? Noisy. So you say that data is going to be dropped from the tab connector. So you cannot able to see that the other last guy is going to get the chance of getting 100% clarity signal. Now see, one more real-time example I will tell you. There is a cable network TV which is connected with a coaxial cable. We use a coaxial cable in cable TV network. Coaxial media I am using. So let me connect a TV1 is connected here, and TV2 connected here, and TV3 connected here. So as your network is connected, cable TV network means about very longer distance they used to follow. And what is going to happen? The first guy, this is my starting point. This is your ending point. Here there is also one more node connected in a daisy chain manner. TV4 is there. He is getting much more clarity, no doubt, because he is very nearest to your starting point. He also will get, he also will get, but I am not going to give any guarantee about the next point that he is going to get the same clarity as the first and the second nodes are getting, because when the signal is traversing onto the media, there may be a chance of what? Weakness, or the signal becomes weaker. That's the point. What is that? If length is high, if bus length is high, then there may be a chance of what? Weaker. Signal becomes weaker, and the signal becomes weaker. That's why what the people are going to do, cable TV network people, what they are going to do to avoid this problem, they are going to use a what? A repeater concept. So to strengthen the signal, to strengthen the signal, a need of repeaters. What is the problem of repeater? Last session we learned, if you establish a repeater, then what is going to happen? There is a chance of 2.5 microseconds by default delay. When I am saying like this is a start and this is an end, and this is established with repeater. So we want to strengthen the signal. That's why I'm doing a concept of what? Repeaters. Sometimes other people also called as boosters. Sometimes people also called as amplifiers. Now you see, first of all, data will come to this particular point. Already last session I explained what is the role of a repeater, and this data will coming like to the other side. So when you are establishing a repeater, clarity is a superb. That means what? Every node is going to get the same clarity. But what is the problem? 2.5 microsecond delay you are going to see repeater. So these are the important points of your bus topology. So here the thing is that one more disadvantage you want to me highlight, I will also highlight such that no order of network. What is a no order of network? You cannot give a guarantee that among the nodes who is going to be the sender and who is going to be the receiver. I cannot give any assurance. I say that there is a node 1 and there is a node 2 and there is a node 3 who are connected to your bus. Can you give any guarantee that 1 will be the sender or 2 will be the sender or 3 will be the sender? There is no guarantee. But we are thinking in such a way. What is that? We are thinking in such a way that one must be the sender and others must be the receiver. Therefore, there will not be any concept of overlapping or collisions concept. Who is going to be the sender? That's a big question mark. So that is not there in this. Who is going to be the sender? So that is a big problem in bus topology. That's where there may be chance of what more collisions in bus topology. So these problems can be avoided. These problems can be avoided. The concept of what? A ring. So ring is also shared mode only. This is also shared mode. Nodes are connected to the shared media. And same chance, what is that? If length of the cable is very high or distance is very high among the nodes, then there may be a chance of signal becomes a weaker. That problem we are going to avoid. How? Ring incorporates with repeaters. Ring incorporates repeaters. So when I establish a repeater, you know what is going to happen. Now, how the nodes are get connected? Let us see in the ring. There is a one important point in that it is based on neighboring topology. It is also called as what? A neighboring topology. That means you want to attach one node onto your network. There is a requirement of left neighbor and right neighbor. So every node connected to ring, every node connected to ring with left and right neighbors, left and right neighbors. That's why it is called a neighboring topology. And as the channel is under shared mode, we see that the channel is going to be under shared mode. Every shared mode is going to suffer from what? Collisions. There may be a chance of collisions. That's why to avoid the collisions, we want to make one of the node as a what? Sender. And the other nodes are automatically going to be what? Receiver. So what I am going to tell you here. So only one node can able to send data at a time. Can able to send data at a time. So when you say that can able to send data at a time, then we are going to see that only one particular sender always and all are going to be become receivers. Very similar to bus topology one. So we are using a concept of what? Broadcasting. Why broadcasting? When I post the data onto your ring, then automatically it circulates and going back to everybody else. And we are also using a concept of what? Off duplex. Why off duplex we are using? Please understand, only one sender you are going to find always in that. Now, how the data is going to be transmitted? Observe. There is a node 1 and node 2, node 3, node 4. There is a long trunk cable which is under shared mode and all the nodes are got connected, and these nodes are being connected to your ring with the help of repeaters if the length of the ring is very high. Otherwise you can able to have up to, if it is a twisted pair, up to you can have 500 meters distance as far as 10 base 2 concept. Now you observe carefully. If N1 would like to act as a sender, So immediately what I'm going to do, your ring is being incorporated with the concept of token mechanism. The ring is incorporated with a token mechanism. Now I am keeping this ring topology the form of token ring concept. So when the ring is incorporated with a token mechanism, then what is going to happen? Observe carefully. Now entire ring is isolated by token only. Entire ring is isolated by token. So now the token is nothing but consists of small amount of data, and which is a controller to entire your ring, and the nodes are also supposed to consult your token in order to transmit your data. Now you see that token is initially circulating. So as long as token is circulating in the network, in the ring, nobody is interested to transmit the data. So you can say that a ring is a free. If token circulates, if token circulates in the ring, that means what? Nobody is interested to send data. No one wish to send data. So I can say that this kind of a mode is ring. First mode is what? Free mode. This is a ring is under free mode only. And for example, you see a node 1 would like to transmit data. So simply they are not going to paste the data or post the data onto your media. What they are going to do? First of all, a node has to consult your token. If a node wish to transmit data, if a node wish to transmit data, what you need to do? Then that node has to capture the token. Then that node has to capture the token. So once the particular node capture the token, then what is going to happen? Ring becomes busy. That means what? The token stops circulated. When the ring becomes busy, when the token stops circulated or rotated, then you can say that the ring is busy. So this is the second mode of your ring. So here we guess that node 1 like to access the ring. That means you would like to transmit the data. Then we want to alert the all other nodes that it's unlike your bus only. Please understand. You are going to alert to all the nodes that I am ready to transmit data as I have captured the token. That means what? This particular token, whatever is there, the token is being capsulated by this N1. Then immediately the token circulates, stops. So everybody will understand that as the token is not moving in the ring, then automatically everybody got to understand that the ring becomes a busy. So I must not be in a sending mode, I must be in a receiving mode. So whoever captured the token, then he has given an alert to all that I'm going to become a what? Sender. This is very, very important. So you see that always you are going to see only one sender at a time because your ring is a completely organized by a concept called a logical ring. Therefore, you can guess from this diagram that as N1 captured the token, then N1 becomes the sender and all other nodes and others becomes receivers. Others become receivers. So therefore, N1 start to transmit the data, and this data will come to each and every node, and this data will come to each and every node. Finally, it has come to me because it is a broadcasting concept. Now what will happen? After the transmission, after transmission, then we want to say that I have completed the transmission. So if anybody is interested, you can able to transmit the data as I am releasing a what? a token. So what that node will do, a node do insertion of token. So when he release the token, insertion is nothing but release the token, then again what will happen? A ring becomes to the previous mode. That is called a ring becomes what? Free mode only. So my dear friends, because of this point, it is completely advantageous than your bus topology. In bus, you cannot able to determine that who is going to be the sender, but in ring, you can clearly identify that somebody is a sender and others are going to be the receiver. So ultimately, we never see a concept of any kind of a collision. This is the advantage in a ring topology. And the remaining end to end, everything is same except this particular point. How it is been under controlled access. This is called as a controlled access. Now you see what are the advantages. The advantages, as I said, no collisions because we have a mechanism to identify or detect only one sender at a time. Because of that, there is an order of network. Order of network is nothing but order of sending. Order of sending. And you also see that it is inexpensive because of only one cable. But apart from this, you see that these are the main advantages. Many are there, but main I have written. And disadvantage is that here also there is no concept of what? No privacy, no security. These are the problems which we are having, especially in. And one more thing, that if intermediate node fails, that means if any neighbor fails, then friends, you see that then a node cannot transmit data. A node cannot transmit data as it is a what? Completely neighboring topology. That means what? How it is formed a loop. That's very, very important. How it is formed a loop. I said that every node requires a left and right neighbor. So I have left neighbor, I have right neighbor. Then only you can able to place the channel. So my left neighbor is N2 and my right neighbor is N3. You want to place the N2. N2 also required left neighbor and right neighbor. So I'm taking my right neighbor, left neighbor is also there for me, and N4. And you want to place this node, there is a requirement of left and right neighbors. That's why it able to form a concept of circulated fashion. It can also be in any kind of a fashion, but you see that we want to say ultimately what? Loops. You are going to find a loops, especially in a ring topology, because every node requires a what? Left and right neighbor. Automatically this particular topology formed a loop, but bus is not like that. Bus is having a what? Uniform distribution such that one start end and other one is a what? One end of the medium. Okay friends. So apart from these two, we are also having a dedicated mode topologies. What are the dedicated mode topologies? They are the first one is a star. So very famous nowadays we are using in a LAN. So one of the LAN topology nowadays which we are using is a what? Star. And you want to say that in internet and others we are going to use the concept of a tree, and some corporate companies are following a hybrid topology. So why star? Star, you say that media is not in sharing, is not under sharing. So when I am saying this important point, when the medium is not shared, there is a requirement of what? 1:1 channels. So when I say 1:1 channels, indirectly you are using the concept of what? Point to point. Point to point is nothing but is a unicasting. Last time we learned. And next one is that when you are saying a 1:1 channels, then there is no concept of what? Sharing of your medium. Hence you are seeing that ultimately a concept of what? There is a 1:1. So I'm having some kind of a privacy as well as some kind of what? Security. And because you are using a 1:1 channels, it is eligible for what? Full duplex channel. When I say that full duplex channel, it's advantageous than me. Your link efficiency can be maximized because any person can able to transmit data. Bidirectionally, it is possible. But what the star is saying, what is the basic principles of star? When I am saying a basic principle as a star, and one particular device is going to act as a central controller. So one device acts as central controller. So now you're all guessing what is the central controller which I am going to give you or which I am going to present you. You know, without central controller, you cannot able to form a star network, my dear friends. Why? Because I am not using any kind of a shared mode. Now I am using either hub or a switched technology. So now, as there are multiple ports are available to this particular central controller, and the nodes can able to attach the channels to that. So I'm trying to attach using a 1:1 concept. Naturally, these are all the works are going to be done by backend network admins and system admin. As we are enjoying internet nowadays, in the sense that is a lot of effort by your network admins and system admins. They are going to arrange a complete network without having any kind of a collisions and without following any kind of your link efficiency. Really, if you would like to become a network admin or a system admin, take a Microsoft certification or a Red Hat Linux certification or a Cisco certification, then you are going to be called as a network engineer or a systems engineer. Now you see the nodes are get connected, and if people are paid high salaries, if you really become a network engineer or a system engineer, and these nodes are being connected to each and every port which are there in your hub and switch. Don't guess that star is like a star. It's like a physical star. Here star represents, we are saying that it is a 1:1 topology, as all the nodes are get connected 1:1 manner to all your ports. Right friends? Now you observe carefully. So everybody, all nodes can send and receive at a time, can receive data at a time. So this facility is there. And next important point is that N1 must send data to central controller, not only N1, if anybody. First you need to send data to central controller, then central controller bypass or transmit your data to other node. Central controller transmit to other node. Okay friends. But instead of switch, if you are keeping a hub, again it is going to be what, broadcasting only. That's why we are not believing in hubs. We are going to believe in a star, especially switches only. Because switch is going to do unicasting, but hub is going to do broadcasting. Okay? Because hub is called as a what, multi-port repeater, which works like a broadcasting only. So all are advantages with the star. But what is the disadvantage? Yes, there is a disadvantage. Is that? Please understand carefully. The disadvantage is if central controller fails, which I am talking, if hub or a switch fails, then I can say that no network in this. Immediately you have to replace the switch or hub, then you can able to have the connection. Otherwise you are not going to transmit a single bit of data as you are unable to connect to your network. So what is the real time? Real time example I already shared, your college networks. All your college networks or all offices networks, all bank networks, they are following a switched topology only. Switched topology is nothing but what? It is a star topology only. And now there is a concept called a tree. What the tree is saying? It is a collection of stars. I already said what is the problem with a star. What is the problem with a star? If a central controller fails, which may be a switch or which may be a hub, I don't mind. Whatever you are going to keep, both are LAN devices only, LAN forming devices. And this is a one switch, and I am saying that this is a another switch. and this is going to be another switch. Now you see, now I'm going to combine all the switches together. Now we got one more star here. This is going to be the centralized switch. Now you see friends, if this switch fails, I don't mind. Still you can have a work with the other particular switches. If this switch fails, I don't mind. Individually you can able to work with other particular networks. When I am saying a one switch is nothing but a one LAN, here one switch is nothing but a one LAN, here one switch is nothing but one LAN, here one switch is nothing but a one LAN. This is the concept of a tree. So all big companies and corporate companies are following a tree topology, which is acting like a star. And the last variety of network is mesh. What the mesh is saying, it's a super, especially we are going to use an ad hoc networks, this mesh topology in Wi-Fi's. What is a mesh? Please understand, you know satellite. If you look at the satellite network, it is a concept of ad hoc network. So what the mesh is saying that I do not want to use no shared mode. I do not want to see that any medium is going to be under shared. And the second important point is that I am also not believing in central controller. No central controller. So how are you going to form? So how are you going to form the network in this? As a medium is not shared in the sense as I supposed to want to use 1:1 channels. 1:1 channels mean there is a requirement of central controller. I am not going to use either hub, I am not going to fall, or I am going to use any kind of a switches, but how are you going to connect? Yes, every node get connected with all other nodes, get connected with all other except me, n minus 1. So therefore it is a very expansive, because to form a mesh, to form a mesh network, need of n into n minus 1 by 2 channels. This is important. N into n minus 1 by 2 channels, and every node requires n minus 1 Ethernet ports. Every node requires n minus 1 Ethernet port. Why? We will see. Because of those 2 points, it's a highly expansive. It's a highly expansive because of what? Many channels. Because of many channels and many Ethernet ports. So now I'm going to show you the presentation of your mesh topology. N1 and N2 and N3 and N4, they want to communicate. I'm not using any kind of shared medium. I want to see the dedicated mode medium only. So here to here 1:1 channel, and here to here 1:1 channel, and here to here 1:1 channel, and here to here we are having a 1:1 channel. Now N1 got connected with N3 and N2, and N1 is not connected with N4. Again there is a requirement of what? 1:1 physical medium. Again there is a requirement between N3 and 2. So my dear friends, there is a requirement, as I said, that n into n minus 1 by 2 medium channels required, because every node is going to connect with all other nodes. That's why it is well suited for Wi-Fi's. And I already told you one thing. So there is a node 1, node 2 and node 3. You want to form a mesh. Every node is supposed to have Ethernet ports. Otherwise you cannot able to connect them. Every medium channel requires one Ethernet port. Back of your system you could see the Ethernet port. Now you see that this port is connected to this using a twisted pair, and this port is used to connect it to this using a twisted pair. And now N2 got connected with the left as well as N2 got connected with the right. So N2 got finished, but N1 requires, N1 again is trying to connect with the what? N3. So my dear friends, what is going to happen? A node is supposed to require N minus 1 Ethernet ports in order to connect to other particular node. So I'm drawing it like this. So this port is dedicated to this, and this port is dedicated to this, and those ports cannot be used by these two, and there is a requirement of what? These two are supposed to have a concept of dedicated port. That's why a node, as there are three nodes are there or three computers are there, so I'm saying that there is a requirement of what? N minus 1 Ethernet ports are required. Every node is supposed to maintain this rule. What are the advantages? You say the advantages, if I am considering, please understand, it's a wonderful, what is that? Security. How your mobile Wi-Fi is under security because of this reason. And privacy, you say that your satellite network is under privacy and security, and as well as what? You say that, and your line efficiency because of 1:1 channel. These are all advantages, and there is no collisions in this, as we are having a concept of what? 1:1 channels, no collisions. All are advantages. But what is the problem? And troubleshoot. I can easily identify the troubleshoot. If any link is broken, yes, I can easily identify that because that port is not blinking to you. When the port is not blinking, the alarm, that means what? I can able to understand that there is a link failure. Immediately I could able to rectify it. But what is the problem? The only one apart from this is what? Expansive. And you say that complexity, your structure is a what? Complexity. Why? If I am saying there are 5 nodes I want to put in a mesh, 5 nodes I want to put in a mesh, therefore your motherboard, please understand, your computer is nothing but I am talking about motherboard, has to have, naturally you people are having only one Ethernet port only. If you want to configure a mesh with a 5 network, you're supposed to have 4 Ethernet ports. So this will connect to other, and this will connect to other, this will connect to other, this will connect to other. Soon after some time, your motherboard is completely configured with Ethernet ports. It's a very complex structure. That's why we cannot able to form a physical mesh using what? Those many channels and those many cables, but it's a well built and well suitable for your ad hoc network. My dear friends, so these are the topologies, and we have the last variety, hybrid. Hybrid is nothing but, you say, some companies follows bus, and some companies are following a tree, and some companies are following your mesh. So whenever you see that this kind of, it's not homogeneous, heterogeneous things are there, then there is a requirement of what? I want to form these networks. How are you going to form? Then there is a requirement of what? Converters required. In order to have this communication from different kinds of topological nodes, then there is a requirement of what? Converters. So with the help of converters, I can able to do a concept called conversion from one particular network or one particular topology to other particular topology. We are using especially converters or translators in a hybrid topology. Dear friends, so we learned few of the topologies, that is shared mode we learned. In shared mode, one is a bus. This is dedicated to cable TV. And the other one is a ring. This is dedicated to IBM token ring. And if I'm saying that non-shared mode, in non-shared mode, the well popular topology is the star. Star is nothing but what? Every node is going to connect with a central controller. That's nothing but a hub or a switch. So now I have multiple stars here. So that's called a tree. And we also see that uh, this is a typical one. What is that? We are having the third one, that is called a mesh. And you want to have a different varieties of topologies you want to get connect, then there is a requirement of what? A concept hybrid. Well, friends, so especially in topology, whenever you are saying, there are some chances of collisions and there are some chances of redundancy of the duplicate packets. There are some chances of loops in the network, especially ring, and there are some chances of what? Delays in the your routers. So that's why you need to design your topology in such a way that you're not going to have any kind of these problems. So that's why easier way to configure your nodes, especially in the companies, better you follow a concept called what? Star. Star will give you 100% accurate topology. That's it, friends. So these are the basics I need since the start of the class. That's nothing but I started with a backbone. Please understand. I started with a backbone. Then we learn peer-to-peer communication. Then we learn types of switching. These are all I need. And we have a concept called transmission modes also. I said parallel and serial. Those who not watched so far, please watch these lectures for further computer networks classes. I need this help. And the fifth one, I spoke about transmission technology and your communication mode. Then also I discussed about organization of layers, especially where you are going to keep your media like routers, hubs, switches, gateways, and firewalls. And we discussed about topology. So please watch all these lectures before starting the next chapter. So as I said that tomorrow onwards we are going to see about IP addressing, which is one of the main responsibility of your internet layer or network layer. Tomorrow onwards we are going to see a very important 2 to 3 marks question in real time. And the companies also, if you become a network engineer, you're supposed to know that how to configure the subnets and supernets. So you need to have a concept of IP address. Why? When you connect it to Wi-Fi from your mobile data, whenever you switch on mobile data, then you are going to get one IP, which is working with the ARP and RARP protocols. You need to learn them, and when you connect it to Wi-Fi, automatically you are being identified by others, and you get one kind of IP address. So what is the use of IP address, and how you able to communicate with others? Without IP address, you cannot able to communicate. So such kind of things we are going to discuss from tomorrow's to next few days. And what is it today's one more session schedule? Today evening 6 p.m. I discussed many of the topics. So all these topics I discussed in one video. Please watch them since September 1 to September 9. Almost all 9 videos I covered. Please watch all the 9 videos because you want to attempt today's quiz, which is starting at 6 p.m. So quiz on your fundamentals, whatever I taught in the videos. From 6 p.m. it is going to start it. Please all of you participate. So please download Unacademy student learning app. I'm going to discuss on that. So all of you please download. It is a free. You just download and access the 6 p.m. live free quiz session. So that you're going to see that what kind of a questions or what kind of a stuff is going to be asked by the examiner as far as a fundamental, that is a chapter 1 concern. And tomorrow, as usually, we have the sessions from 2 p.m. That is nothing but what? IP addressing, which goes to 4 to 5 days. The IP addressing concept, because many flavors are there. That is from 2 p.m. I am going to start from 10th September. So especially tomorrow onwards 2 p.m. And your quiz today, please download Unacademy student learning app. Just to register with your mobile number and you can able to access this. And the next important announcement that 14th September onwards, I'm going to start a plus course. The plus course, I'm coming with initially DBMS as per as many students request. Otherwise, I would have started either operating system or network, but I am starting a DBMS, which is the timings are from 7 p.m. to 9 p.m. daily 2 hours class. So it is a comprehensive course which consists of much theory according to your syllabus as well as a questionnaire also. I'm going to deal in that only. So those who have not taken admission, this is only for plus students, only paid access only. So those who are not joined so far, join immediately to acquire 9 to 10 marks or 100% confident in interviews. Especially they may ask many number of questions on DBMS only. As I was interviewer, so I know that what kind of questions are going to come. So those are going to be dealt in DBMS. But all you need to do is that take admission in an academy, then you become a plus member, and you access this course from 14th September. Timings are 7 p.m. to 9 p.m. So anyhow, tomorrow we are going to meet once again on YouTube. That is from 2 p.m. to learn a very fantastic chapter that is called IP addressing. And today, all of you join whatever the fundamentals you learned through my YouTube lectures or whatever you learn as per as the basics of your computer networks. Test yourself where you are, ping yourself where you are, what is your confidence level in the today's quiz session. Thank you all of you for sparing a valuable time. We'll meet at 6 p.m. on Unacademy student learning app. Thank you very much.